looking at FRQ that has the Taylor's polynomial error in it and other stuff. So this is how we connect this to ABs. How they get the AB subscore is they find some other questions that cover the whole course. So in A, write the line tangent to the graph of. So we need to do what? We need to find a point and a slope. So what was our point?
3.
Okay, so we've got 3, 6, and what's our slope?
2. Wait, no. Negative.
So M equals -10. Write an equation for the line tangent to the graph and use it to approximate. Bless you. 2.5. So we've got y minus 3. So we're going to put 3 on the other side. It's going to be positive 3. That's our starting place. No, it doesn't. It's 6. Sorry. I'm waking up. It's all good. 6. And then slope is -10. Minus 10x minus 3. That makes way more sense because this is 2.5 and it's near 3. This looks like the beginning of a Taylor's approximation. So I'm going to start writing them like this because then they'll look like our other stuff. This is just a first degree. Neat, right? Yes. Connection made?
Connection made. I see now.
Okay. So now we're going to plug in 2.5 and we're going to say y equals 6 minus 10 times -1/2.
Mm-hmm. Yes.
So that's 6 plus 5. So y equals, or approximately, is equal to 11. So I squeeze that in there. And I doubt I can squeeze anything else in the little line there. Okay, how's that? So that part was fine?
Yes.
All right.
That part was good.
So B, write a third degree polynomial with the center at x equals 3, which makes sense because this is our data. This is the center, x equals 3. And we're going to third degree, so we need it to be x cubed. So we're going to, and then we have to approximate. Okay, so here we go. Third degree polynomial. So we need the first, this is the first thing that we plug in, right? So we're going to go Taylor polynomial t base 3 of x equals 6. And then the next one's going to be -10 and x minus 3 to the first degree. And we could put it over 1 factorial, but we're not going to because that's too much stuff to write. And then the next one's 16, so plus 16 x minus 3 squared over 2 factorial. And we need one more, so we've got minus 24 x minus 3 cubed over 3 factorial, which you could simplify if you want, but that has everything that we need there. So we did that part. So if we were doing points, which I didn't, I think I did print the points on here, but I'm not going to figure them out. This would be a point for writing it down. You don't need to simplify it, and you could now plug in 2.5 and see what you get. So we're going to have, do I have room for it?
I got
13.5. Did y'all all get 13.5? Yeah. So I can write my notation t underscore 3 of 2.5 is approximately 13.5. Okay.
Use the wiggly.
You don't have to use the wiggly, but you can use the wiggly. That means approximation. They're not going to count off if you say equals because this notation means approximation. So the approximation's in there already. Okay, so then is there enough information to determine whether f has a critical point at 2.5?
I said no because there's like no function.
Because we don't, I mean, if you had 0 for a first derivative or 0, like we don't even have a derivative. We need a critical point means we need to have derivative. So they're just throwing an extra thing in there to see if you're just going to wing it. No, there's not enough. There's not enough information. Explain why not. Critical point would be f prime of x equals 0.
So
we don't have that. We just have an approximation for the y value. We don't know anything about that y value. So we can't make a determination there. The fourth derivative of f satisfies the inequality that the fourth derivative is less than or equal to 48 for all x greater than 2. Use the Lagrange error bound to show that the approximation found in part B differs from f of 2.5 by no more than 1/8. So I wrote this down yesterday. This is for C. We've got the absolute value of x minus c. I need an absolute value there. And then to the next one. So this is really the fourth, right? I don't need to write n plus 1. I could go for the fourth. So here's the actual equation, factorial, times the max of, and I'm just going to write fourth derivative here because the notation is weird and that might make the most sense for us. So x minus c, we already know the center. What's that going to be? Three. It's centered around 3. We actually need to find the value at 2.5 minus 3. So this is the x value we're plugging in, just like in B. It's centered around 3. We're doing the fourth derivative because, why are we doing the fourth derivative? Because 3 plus 1. Because they gave us the fourth, so we need that. But also in B, we did the third, right? So we did the third, the fourth would be the next one, and that our approximation is only as good as many derivatives as we insert into the polynomial. We only have 3, so the fourth one's going to be what tells us about the error. Okay, 4 factorial on the bottom, and what do they tell us about this derivative?
It's less than.
The maximum we could be off is 48 here, because this derivative is the absolute value of it is less than 48. So if we multiply this by 48, the maximum of the fourth derivative, then this represents the error that we could be off. So our approximation was 13.5. This is going to tell us how close we are to the actual value. Trying to make connections here. So what is that going to be? This is 1/2 to the fourth over 4 factorial. 4 times 3 times 2 times 48. So here we go. This is 2, right? I don't know why I changed color because they're the same. And then I've got 1/16 times 2. This one's dead. Okay. Equals 1/8. And the question was, is less than or equal to 1/8 here. So there you go. We connected it to the problem. It is less than or equal to 1/8 by no more than 1/8.
So then what does that mean?
Use to show. Here's the show. We used it. We showed it.
So it means that the approximation.
So, yeah.
So it means that the 13.5 is no.
So it could be 13.5 plus 1/8 or 13.5 minus an 8. That's how close our approximation is.
And is that all we need to write? Or do we
Yep, that's it.
Okay.
So you want to actually pull out whatever they say here. If they just said 1/4, we would have said 1/8 is less than or equal to 1/4. So whatever they ask for, you want to show that at the very end that you're comparing what they gave you in the problem to what you got in your show. Yeah, that's the actual comparing part, right? I mean, you could say in words 1/8 is equal to 1/8. We showed it. You could write it in words, but this is the math that would show it, which isn't just you going, like in Algebra 2, we would do math and get to an answer and we'd circle it, 12. So this is us showing they gave us the problem. I kind of circled it like I'm saying I'm connecting it back to the problem, which you want to make that connection. Okay, so D. D was a question we hadn't seen at all before. We're trying to make sense out of it. What is the coefficient of the x minus 3 to the third term of the Taylor series for f prime, the derivative of f about x equals 3? So this is not the Taylor series for f. This question asked about the Taylor polynomial for f. This is asking us to take that and then take a derivative So how do we get this derivative? Like, what term would we take if we had the whole polynomial written out?
Fourth.
We'd have to take the fourth, right? Because it would be 1 degree less, would be the third. No.
Do the fourth and take the derivative.
Yes. So
That would be 32.
So here's what I'm going to write. This is for D. The fourth derivative centered at 3, if we had that value, right, and we took a derivative, it would have a power of 4 on it. Like it would be the fourth degree, which we didn't write this one out. I guess we could have take a derivative, but here we go. It would be, and I'm not sure I'm explaining this very well, but we'll see. It would look like this in the series. Like it would, this is not equal to, like in the writing out in part B, it would have this format to it where we would write this over 4 factorial, and then we would take a derivative of the function part. Does that make sense? A little bit? If we took the derivative of this function part, it would have a power of 4 on it. So we would say 4 times the inside. What was, oh, back on my chart. What was the fourth derivative of x? 32 over 4 factorial.
Why did you, I get everything else that you did, but why did you do it multiply by 4?
How could I write it a different way? It'd be 32 is this value. It's going to be the fourth derivative. The notation is weird to try to explain it because I'm not going to chain rule it in the same way.
Because when you just do 32 times x minus 3 to the 4th over 4, and then you simplify that, and then that would be...
So I already know this derivative's value. So I have to include that. I know I'm not explaining it well. The 4 is from the degree and bringing it down. This part is from how it would be set up. The 3 is already taken care of because the 3 is from the chart. So like the x minus 3 part that you were saying you would see in there, we already have that value of the derivative. And so I'm going to finish out this problem, and then I'm going to make a note to myself to find some more so we can talk about it more and do some more practice. Because this is the first of this type that we've seen together. Because the final answer ends up being, so 4 factorial is 4 times 3 times 2 times 1, right? So it ends up being 32 over 3 factorial, or 32 over 6, or 16 over 3, if you took out a 2. Either one of those answers. And it's because we took a derivative and brought that power down. Like this would be the term, I don't know how to explain it better. Okay, so make a note to myself, find more. Like this. All right, so find the second degree, and my whole punched out the D, the D part, so it's not there, but it really is there. Polynomial for h of x centered at x equals 2. So if we didn't know any of this, what would we do to find the second degree Taylor polynomial? Like what stuff would we need? We would need h of x, right? Then what? H prime of x? And h double prime of x. Okay, so without ever what's given, Taylor polynomial is going to have these things. And then we look back at our information and say, can we get it? So looking back at our information, we have a h of x is actually equal to an integral. What does the integral mean?
Area.
Integral means area. Integral means area. You're told that the area of this part is 67 over 8. So we have some area. That's handy. So to think about that area in another way, h of x means the area from 5 to x. What's our thing centered around? 2. So we need that, right? That's the like h of value that we need to find our stuff. So over here, this is all h of 2. Does that make sense? Need that.
Okay. Because that's the center.
Uh-huh. So that's going to determine all of those actual coefficients that I need. So I know that this is 67 over 8. If h of x is the area from 5 to x, how does that relate to the picture we're given?
It's just like beyond the area from that. What you know, like you plug in 2 for x and then flip it and make it negative?
So Zoriani's thinking x must be out here, which is a start. Emma says, well, we need it to be 2. So, and that's awkward. So instead, we can go h of x equals negative from 2 to 5 of f of t. Remember when we go in the backwards order, then we put a negative in front of it. We're counting backwards, so we have a negative area. So do we have the area from 2 to 5?
Yeah.
So now we know what h of x is. It is
negative 67.
Negative 67 over 8. How about that?
That's as far as I got.
Okay, so we found that. What does h prime mean in relation to our picture? What is, or even not the picture, what does h prime of x mean?
So take away the integral. So you get f of t or f of x. Yeah.
So if we took the derivative here and the derivative here, this would cancel and we would get f of t. This is f of 2. So second, you need to remember that f prime of t equals h of x. And so h prime of x, did I do that backwards? H prime, oh wait.
H prime of x equals f of x, right?
I was thinking backwards. I'm gonna start over. Okay, if I took the derivative of both, this would go away. So h prime of x equals f of x. Which is f of t, sorry. Well, no, once you plug it in, it would be x, right? I mean, with the fundamental theorem of calculus, since this doesn't have a chain rule, we could just plug it in. So you're right, I'm right, we're both right. It equals the graph. So it equals the graph, which is the graph. The graph. So what is f of 2? You can't tell. It was printed on graph paper so you could tell. Y'all, I printed on graph paper. I really promise I did. I made it dark.
That's why we got so confused.
I went to the copy. I pulled out of this notebook graph paper and printed it as dark as I could. And then I left the copier and came back. Well, shoot. This is 3. I'm really sorry.
It's okay.
It's 3.
We're going over it
now. Okay. And if you knew that was 3, that will help you with the next thing. So, how about h double prime of 2?
That's the slope.
That's going to be, if we took the derivative of this middle section, we would get derivative of first prime is double prime, derivative of f is f prime of 2. How do we get f prime of 2? Now that this is supposedly graph paper.
Wouldn't that just be the rise of a runs?
So that would be?
2/3? Wait, no. Rise. Yeah, 3.
Wait a minute. Okay, so what does slope mean? How is slope calculated? Yeah, in a line,
Y minus
F is this curvy thing. F is the curvy thing. But there's a tangent line to the curvy thing that represents the tangent line. See it? And that slope is 1. So for this one, we need the tangent line. And its slope is 1. And so we have all of our parts now.
Oh, I see. Just count it.
So needed graph paper. Teacher failed. Sorry.
Teacher failed.
I tried really hard not to fail. Like I had lots of things in place so that I couldn't fail here. So what do we need after that? We need to write our Taylor polynomial. It's going to be second degree. So we're going to write t underscore 2 of x equals. What goes first?
Wait, negative. Oh.
Yes.
Why are we using 1 and not 3? Like, why are we using the tangent line and not the regular?
Okay, because this could look anything. This could look like, this could really look anything. Okay. It has to be from the tangent line because the tangent line is the best approximation of a curve.
Because we're looking at that.
So we're not really comparing. I mean, the function, see, it went down. I mean, it has to be the tangent line. That's why it's there. Now it looks like Medusa. Okay.
It looks beautiful. It's a beautiful problem.
What? Yeah. So when we do that, how do we do that? The first term is going to be the starting value. So this is just a term, 67 over 8. But it wasn't hard. It seemed like 67 or 8, this is going to be a really hard problem. It's just, we just throw it down. Boom. And then plus, then what?
3 times x minus 2.
X minus 2 to the first power, which reminds us to put it over 1 factorial, which we're not going to do because it's too much stuff. We did this one and this one, so we have 1 plus 1 x minus 2 squared over 2 factorial. Taylor polynomial.
Yeah, I was like,
I'm sorry, it wasn't graph paper. I was like, okay, pull stuff out of copier. Go.
Miss Haight doesn't like us.
Also, Miss Haight, can we go for number 9 on the quiz as well?
Yes. I do not know where mine is. Okay, so it took me a long time to figure out 9. I felt really smart when I finally got it because I kept, let's play with it and see what.
Yeah, Emma showed it to me and I was like, oh my god.
So 3 halves.
I was like, I should just not go to college.
Plus 9 over 16 plus 27 over 128 plus 81 over 1024 plus ... Okay, before we go solving it for people who figured it out, what do we see? What patterns do we see? Like, just write anything you see. Like, let's think about the top.
Everything is times 3 over 8.
Okay, so we don't go there yet to the answer. We want to just play with it for a minute. Okay. What do we see on the top? Do we see 3s? Does everybody see 3s?
3s.
Oh my goodness. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Like that would be the place I would think most people would start at. On the bottom, what I see first are powers of 2. And that's where I started. Did anybody else start in a different place?
I started.
Okay, you saw the times 8. That's amazing. So I'm going to write what I saw. This is 2 to the 6th, 2 to the 10th. You saw 2 times 8. Wait, you saw 2. And then 2 times 8. And then 2 times 8, 16 times 8. Is that what you saw? Okay. And then this would be this one times 8. Times 8 every time. So if that's the case, and so Emma said this one was times 3 every time. This one would be times another 3, times another 3. How do we take these two guys and say times 3 over 8 each time?
Wouldn't that be your R and then you just plug it into the A over 1 minus R?
Yes. So if we multiply by 3 on the top every time, and so we need this in, and then the 8 every time, that's our part where we multiply every time by something. So we have the summation, we have we're multiplying by, what did we start with to end up with 3 halves?
What did you start with? It'd probably be, not 3 halves is what you started with.
Okay, so if we start with 3 halves, then how do we, what else happens in our summation so that we can have 3/8 and this makes sense? What does n need to be? 0. N equals 0 to infinity. And that's how it works. Like it actually works if you say 0 and then you have 3 halves, and then you put 1 and you're like 9 over 16, and then 2 is going to be 3 times 9, and that'll be 2 times 64. And then you can say a over 1 minus r and find a by plugging in the first term, right? So if you plug in 0, that becomes the first term. In this, yeah, so in this case, this is actually the a, like this is a, but it's really the first term. So it's better to plug this in and find out what you get. So we get 3 halves over 1 minus 3/8. So 3 halves over 5/8. 3 halves times 8/5. 12 over 5. No. Wait, 4, 12 over 5, is that right?
That's right.
Oh, I didn't, when I did it my time, the first time I said 24 over 10, and that was easy to pick out my answer, 2.4. I was like, how did I do it before without having to think? 24 over 10 was 2.4. So that was actually a non-calculator problem, but I hadn't gotten to it when I gave you the quiz, so I was like, give it up. And I don't know, sounds like Emma and Luke found it right away. I didn't find that 8 right away because I saw powers and I could not figure out how to make it work. I was all n plus 1, n minus 1. So more practice would make this better. Okay, so that was 9. Better?
Those are better.
It's about finding the pattern.
But can we do
To the negative 0.95 McLaurin, so center is 0. Sorry, center is 0. We need the same error smaller than 0.001. So when we do this and we plug in different values, we're going to see when we get less than 0.001.
Is A the center?
So, yeah, should that be A? Why I have A there? Center. Okay, so we've got, and it's the absolute value. So we don't care, we just care about the difference. So what's the difference between 0 and negative 0.95?
0.95?
We have 0.95, and it's positive because we took the absolute value. 2, the n plus 1 over n plus 1 factorial, and we're trying to see if it's less than 0.001. So the best thing to do for me, when I was just putting this in the calculator over and over again, was to put in a fraction and say 0.95 raised to the, it starts with 3 in my list, so I'm going to go 3. So really I need to go 3 plus 1 is 4, right?
Mm-hmm.
That is not what I needed to do.
If the center was not 0, how would you do it? Would you do minus, like?
Yeah, so you'd figure out that value by subtracting from the center.
Okay.
Inner. Sorry, there we go. And then on the bottom, it's going to be 3 plus 1 is 4 factorial. There we go.
You got them fast.
And we get 0.33. Is that less than what I need? No. 3 gives me 0.03394. And then I can arrow back up and do the same thing, but go 4. Go 4 plus 1 is 5 over 5 factorial. So I don't have to go find the factorial again, which is gold. So this is 0.006. So with 4, I got 0.0064. It's probably going to be 5, right? 5 is what I'm plugging in for n. I'm going to put the same thing in. but go and change this to 5 plus 1 is 6 over 6 factorial. And I get, oh no, it didn't. 0.001. 02. Is that less than 0.001? Oh, there's the rest of it, Hutch. Sorry. There it is in my notes. And so now I need to go 6, which is definitely going to be cool. And that's actually going to be 7 over 7. And I've got enough zeros there that I'm good. 1.3858, and then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. There we go. So that's cool. So 6.
See if I can. What? How is it? I'm sorry. I was.
You're doing your own problem.
Yeah, I was following along using the same methodology.
So this, I said yesterday, we want to put it on a note card so we can remember it. But we're trying to find x minus the center, and then we're doing the next term. So we plug in that value, and it would be the next term, whether that's less or not. And then you just keep doing that over and over again. So go back and play with those. When you get the ones that have x in it, we're going to work on some x stuff now. Let's see if we get another easy one to try. Yes. Okay. So now we have example 2. We have sine of negative 0.1. Also Maclaurin. So the center equals 0. So 0 subtract negative 0.1 is 0.1. So I have 0.1. I mean, I don't have to do that. I just know that it's that difference anyway. But it's the absolute value, so no matter how you calculate it, it's going to be that.
So it doesn't matter that it's sine, you just use that term.
So right. Why is that? That is because the maximum error that sine can have would be 1. The sine function only goes to 1 and negative 1. So because it's a sine function, we can just plug it in. Remember how before I wrote the max part, like I would multiply it by the max value?
Mm-hmm.
And I'll have to look back why E didn't need that. Maybe if we calculated it, it would have still been that value, but it worked out. Yay. Okay, so here I go. The maximum value that sine can be is 1 or negative 1. So the max absolute value that I could use would be 1 or negative 1. I can stick with this basic calculation. And so
start with 2.
We go 2, I'll do it over here. Does that fit in my thing? Yes. So 2 is going to be, fraction again, 0.1 to the third over 3 factorial. And that's going to have 3 zeros. Is that going to be enough? It says 1.667. 1, 2, 3, 4. 1, 2, 3.
I did 3 and I got like e to the negative 6.
But this is 0.0, so I'm supposed to be comparing it to 0.001. So this one's smaller. My 0.2 is in the way. Right, so this one having 3 zeros is smaller because the other one has 2 zeros.
Wait, I'm confused. Okay. Why did you move the decimal?
My calculator says 1.6 to the e to the negative 4.
Oh, sorry.
So this was times e to the negative 4, so I moved it 4 spots, which gave me 3 zeros, which is smaller than this one. Okay, sorry.
Sweet.
Okay, so go back and play with those some more.
So the natural log. We don't. So not the ones with x in them yet.
Not the one with X in them yet.
Ooh, I guessed it right.
That was
Excellent.
Where did the class go? Like, I thought we had a double block.
that was a double block.
Double blocks seem shorter to me now. I don't know why.
Also, I think the announcement this morning ran.
Oh, the announcement was
Wait,
really long.
Missy, could
We
you
really have
flip
a
it
lot of time.
back a little bit? I missed a little bit.
That's true. But I knew we needed time today, but it did that.
I'm sorry,
that
we
helped.
tried.
Oh, I'm not complaining. I'm just saying time wise. Okay.
Thank you for